Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we'll take a look at a couple of word problem examples involving systems of nonlinear equations. First one, we have a rectangle whose perimeter is 20 centimeters and area is 24 square centimeters. Whoops. And we want to find the length and the width. So from the perimeter, we know that 2 times the length plus 2 times the width equals 20. And for the area, we know that length times width equals 24. We actually have some options here. Notice that the first equation, if we divide through by 2, we get length plus width equals 10. We could use substitution there by isolating the length or the width and moving it into the other equation. We could also solve the second, use substitution with the second equation, isolating length or width and substituting it into the first equation. So we've got some options here. Let's go ahead and let's use this approach. If we divide through by 2, we get length plus width equals 10. And if we solve that for length, we get the length is 10 minus the width. So that expression can go into the formula for area. Length times width is 10 minus W times W equals 24. Multiply that, 10W minus W squared equals 24. Let's move everything to the other side of the equation where the squared term will be positive, have a positive coefficient. 0 equals W squared minus 10W plus 24. Subtracting 10W and adding W squared over to the right-hand side. This one we can solve by factoring. 0 equals W minus 4 times W minus 6. So the width is either 4 or 6. What is the length? Well, we know that the length is 10 minus W. So the length would be 10 minus 4 or 6, or the length would be 10 minus 6 or 4. Now technically, the length is always considered to be the longer side of the rectangle, and in this second instance, that's not really true. So we'll go with the width is 4 centimeters and the length is 6 centimeters. We can check this in both of the equations. First, for the perimeter, 2 times the length plus 2 times the width, does that equal 20? Well, 2 times 6 is 12 plus 2 times 4 is 8, and that does add to be 20. We can also check the area one more time. Length times width, 6 times 4, does that equal 24? It does. And so our solution is that the width is 4 centimeters and the length is 6. Now the other one's got a little bit more to it. We've got a box with an open top. So 4 sides and a base, but no top. Has a square base, so the bottom is a square. And the 4 sides are all the same height. The volume of the box is 384 cubic meters. The surface area is 256 square meters, and we want to find the dimensions. So that's the length and the width of the base and the height of the box. And I made a drawing already. There we go. So that picture goes with our scenario. The base is a square, x by x, and the height is not necessarily the same number, that's y. First, for the volume, we know that the volume is base, length times width times height, or x squared times y, and that is equal to 384. For the surface area, we've got the piece at the bottom, plus we've got the 4 sides. the bottom is a square of x times x. So that's x squared plus the each side is x across and y up. So that's xy. So we've got 4 of those. And that is supposed to be equal to 256. Now, in terms of substitution, the easiest variable to solve for is the variable y in the volume equation. So y is the same as 384 over x squared. And we can substitute that in for y in the surface area equation, creating an equation that just has x. So let's do that. X squared plus 4x times 384 over x squared equals 256. X squared plus one of the x's divides out, but we still are going to have an x remaining in the denominator. And 4 times 384 is 1,536. So that goes over x equals 256. Let's clear the fractions by multiplying everything by x. And at the same time, I want to bring the 256 over to join the other terms. So that's going to give me x cubed minus 256x plus 1,536 equals 0. Welcome to big number troubles. We need to come up with a solution here, and because it's cubic, we're not really equipped for doing that. So we would have to use the rational roots theorem, and we would have to start working with different factors of 1536 until we found one. I'm here to help you out with that a little bit. So one of them is 8. So if we know that one of the solutions is 8, I can use synthetic division, 1 for x cubed, 0 for x squared, negative 256 for x, and 1,536 for the constant term. And we can divide out x minus 8 to get the remainder of the cubic that we will be reduced now to quadratic, and we can try to solve that. Bring down the 1. 8 times 1 is 8, and we add. 8 times 8 is 64, and we add. Let's see, that is negative 192. And then we multiply 8 by negative 192. And that is negative 1,536, no remainder. So this equation factors to be x minus 8 times x squared plus 8x minus 192 equals 0. And it would be worthwhile if you could factor this to factor. However, it doesn't factor. Yeah, it doesn't factor. So we have to use quadratic formula for the remainder of the solution. So one of the solutions is x equals 8. The other solution or solutions we'll get from the quadratic formula. X equals negative 8 plus or minus square root of 8 squared minus 4 times 1 times negative 192, all divided by 2 times 1. X equals negative 8 plus or minus 8 squared is 64. Negative 4 times 1 times negative 192, that's going to be positive, and it's 768. So when we add that to the 64, that is 832 all over 2. And then we could try to simplify this, but the directions will ask you to round this to a certain decimal place. On the page I typed, it said to round to the nearest tenth. So I'm just going to round this on my calculator to the nearest tenth. And I should see 10.4, I believe, but let's check that out. Oops, sorry. Fraction negative 8 plus square root, negative 8 plus square root, and I forgot the number already. Oh, 832 all over 2. And there you go. That's 10.4 roughly. If we did the same thing, but we subtracted, we get negative 18.4. So those are the two solutions approximately from the quadratic formula. X is either approximately 10.4 or negative 18.4. But that, remember, X represents the length or width of the base, and it cannot be negative. So this solution doesn't make sense in terms of this problem. So either X equals 8 or X is approximately 10.4. And we actually may have two solutions that work here depending on the height of the box. So the best way to get Y is to use the expression that we use for substitution, 384 divided by x squared. And we'll go back to the calculator here, starting with the 8 squared option. 384 divided by 8 to the second power. That equals 6. So one solution is with x being 8 centimeters and y being 6 centimeters. For the other one, 384 divided by 10.4 squared. And that to the nearest tenth, that's about 3.6, 3.55. So the other solution is if the box is a little wider at the bottom, right? The base is a little bigger, 10.4 centimeters. The height will only be 3.6 centimeters. But in both cases, they have the same exact amount of material for their surface area, and they have the same amount of volume in that box. Now, if you wanted to check, we know that the volume is going to be okay because that's the equation we used. The one that we would want to check is the surface area. X squared plus 4xy should equal 256. And let's see. We'll take solution 1, 8 by 8 by 6. 8 for x, 8 squared, plus 4 times xy, 8 and 6 for x and y. Does that equal 256? Well, 8 squared is 64. 4 times 8 times 6 is 192. And that does equal 256. For the other one, 10.4 squared plus 4 times 10.4 times the value of y is 3.6. Is that approximately 256? And the reason I say approximately, remember, we rounded to get each of those solutions, and y was 3.55. I rounded it a pretty good distance to 3.6. So I'm expecting that this answer is going to be a little on the high side compared to 256, but it should be close. And the further along we would have rounded x and y, the closer we would get to the exact result. Let's try it. 10.4 squared plus 4 times 10.4 times 3.6 is 257.92. If we had used more decimal places, we would have got closer, but this suggests that we're on the right track. So those are the two solutions. Either it's a square base of 8 by 8 with a height of 6, or it's a square base of 10.6 by 10.4 by 10.4 with a height of 3.6. I'll see you in the next chapter.